Okay, let's try a little thought experiment. You're just going about your day, and then, out of nowhere, the entire planet just stops, screeches to a halt for only 5 seconds. What would actually happen? Well, let's get into it.
I mean, really think about that. What would you feel? How much damage could a 5-second pause really do? And when it all starts back up again, would our world even be recognizable? Would it be habitable at all?
So to really get our heads around why stopping is so unbelievably catastrophic, we first have to appreciate the motion we're in right now. The incredible, constant spin that we're all a part of every single second of every single day.
At its heart, planetary rotation is, just what it sounds like. It's the spinning of a planet on its own axis. For us here on Earth, that's what gives us our day and night cycle. But here's the thing, the spin isn't random. It's basically an ancient leftover force from the chaotic birth of our solar system. I want you to picture this. 4.5 billion years ago, there's just this massive, swirling disk of gas and dust circling our young sun. Little bits of rock and dust start bumping into each other, clumping together. And every single collision, every new piece of rock that got added to this forming planet, it added to its momentum. It pushed it, getting it to spin in one direction. And you see, with almost nothing in the vacuum of space to create friction or slow it down, it just keeps going.
You know how a figure skater pulls their arms in to spin way, way faster? It's kind of like that. The early Earth was doing the same thing. As it collected all that dust and rock, it was pulling all that mass closer to its center, which locked in that incredible rotational speed that we still feel today. So, here we are, all spinning along just fine. But now we get to the really dramatic part of this whole scenario. Somebody pulls the emergency brake. The Earth just stops. On a dime. What happens in that split second? And here is the absolute crux of the problem. The solid ground beneath your feet stops. But everything on it that isn't welded down, the oceans, the air, you, me, every single car and building, we all keep going at the Earth's original speed. Why? It's called inertia.
And that brings us to our very first cataclysm. The atmosphere, suddenly free from the ground, basically becomes a planet-sized sandblaster. We are talking about winds of pure, total obliteration. Just look at that number. At the equator, where the Earth spins the fastest, that wind would be whipping around at over 1,600 kilometers per hour. That is faster than the speed of sound, a supersonic windstorm wrapping around the entire globe.
Now, this effect wouldn't be the same everywhere. If you're near the equator, you're dealing with that 1,670 kilometer per hour nightmare. But even further out, in places like France or New Zealand, the winds would only be about 1,180 kilometers per hour, which is still way, way stronger than any hurricane ever recorded. The only places with even remotely mild winds would be right at the poles.
And to put that into perspective for you, think about the most powerful hurricane you've ever seen on the news, the ones that can rip houses from their foundations. Now imagine winds 3 times stronger than that. We're talking winds powerful enough to literally peel the top layer of the Earth's crust right off the ground. No building, not even one made of reinforced steel, could possibly survive that.
So, this obviously raises a pretty big question. With forces like that at play, would you just get, flung off the planet and into space?
Well, the short answer is no, but the alternative isn't exactly great. See, to actually escape Earth's gravity, you'd have to reach something called escape velocity, which is about 40,000 kilometers per hour. The winds just wouldn't get you there. But you, along with a whole lot of other debris, would definitely be sent flying for a very, very long way before crashing back down.
Okay, so as if a planetary windstorm that can literally shred the ground wasn't enough, the atmosphere isn't the only thing that keeps moving. The oceans do too. And this inertia kicks off our second catastrophe, a global tsunami that would literally reshape the continents.
You see, our planet isn't a perfect sphere like a marble. That constant spinning creates centrifugal forces that cause it to bulge out around the middle, at the equator. And that bulge is where a massive amount of the planet's ocean water is held in place.
Okay, so follow me on this because it gets wild. When the rotation stops, that bulge, it just relaxes. Earth settles into a perfect sphere. All that water that was piled up at the equator has nowhere to go but out, surging toward the poles in one unimaginably huge tsunami. But remember, this stop is only for 5 seconds. When the planet starts spinning again, that equatorial bulge pops right back out, and all that water comes sloshing back from the poles. A second continent-sized tsunami. You get hit by a double whammy.
So, the 5 seconds are up.
The Earth is spinning normally again. But what's left after this 1-2 punch of supersonic winds and global tsunamis? The honest answer is not much. Not much at all. The aftermath would just be total. Every single building, all of our farmland, every piece of our technology, gone. Demolished. Billions of people, if not every single person on the planet, would be lost to the sheer force of it all. The surface of the Earth would be scoured completely clean beyond any recognition. Is there any hope? Anywhere you could survive this? Well, maybe. The only conceivable place you might make it is deep, deep underground, in a specially built bunker near the North or South Pole where those rotational forces, and therefore the winds, are at their absolute weakest. It is the slimmest of chances and the most apocalyptic scenario. The good news, of course, is that the Earth isn't going to stop spinning anytime soon. Not for the next few billion years, anyway. Before that happens, our sun will probably burn out and expand into a red giant. But that's a story for another what if.